Contact-cooled rotary screw air compressors with pack protection, V-Shield technology, sequential cooling system, and a time-proven air end. Reliability, efficiency, and productivity. Introducing the new R Series. More than air, peace of mind.
Whether you're a home mechanic or a small business owner, you'll agree to the importance of an affordable, durable, compressed air piping system that's easy to install. Infinity QuickFit takes the hassle out of installing and operating compressed air systems, specifically designed for small installations. Our all-metal piping and connectors guarantee a leak-free system. And don't worry, there's no need to sweat, glue, or thread any of the pipes, because QuickFit's unique locking connectors make installation stress-free. Lightweight, durable aluminum piping is preferred over conventional piping methods such as steel, copper, or PVC. Iron pipes rust and will eventually lead to a major reduction in air quality due to excessive corrosion particles being delivered into the air system. Steel pipe requires a threaded or welded connection, so you'll have to have a professional install it. While copper tubing doesn't rust, it is considerably more expensive and usually requires professional installation. PVC is lightweight and clean, but it's fused together with solvents, and there is a high probability of the components bursting, which makes it a very dangerous alternative. The Infinity QuickFit air piping system will ensure that you never have to deal with those issues again. The QuickFit system is manufactured totally from metal components. Its tubing is made from the highest grade of marine aluminum alloys, which will never corrode. And the fittings are all cast in solid brass and nickel plated. When the two components are combined, you achieve a level of quality that can't be found in any other piping system. Installation of QuickFit can be easily done by any do-it-yourselfer. It's quick and easy and requires nothing more than a simple tube cutter and deburring tool for even the most complex installation. Cut, deburr, and push together. Once installed, you'll be amazed by the appearance of the QuickFit product, enhancing all applications where it's installed. Its lightweight design enables QuickFit to be installed anywhere with no special mounting requirements. You don't need a loading dock or a forklift. Not only is the system itself affordable, but it's designed to fit in specific packaging sizes that enable it to be shipped by any door-to-door delivery service at minimal cost. The packages are lightweight and easy to handle. To further enhance any QuickFit system, you should give serious consideration to installing a PowerMizer system flow controller. Simply stated, PowerMizer is a technology designed to optimize your compressed air usage and reduce waste, as well as increasing the life of your compressor by saving on wear and tear. For more information about Infinity QuickFit, you can find us on the web at appliedsystemtech.com or call us at 704-947-6966.
Rotary screw compressors are also positive displacement machines. These compressors employ two rotating, interleaved helical screws which capture air in a pocket between them. The space in which the air is trapped becomes smaller as it moves down the axis of the screw. The compressed air is discharged from the opposite end of the intake. Rotating screw compressors can be used in applications ranging from 3 horsepower to over 500 horsepower. They are commonly used by roadside repair crews to power air tools and are also used for automobile engine superchargers.
Ingersoll Rand, an innovative company for over 100 years, brings you the innovation history of centrifugal technology at Ingersoll Rand. Ingersoll Rand entered the centrifugal compressor business in 1911 through the acquisition of General Electric's compressor division. The first commercial sale in 1912 was a 100 meters cubed per minute or 3500 CFM turbine-driven multi-stage axial air compressor. In 1917, Ingersoll Rand provided the first successful high-pressure turbine-driven centrifugals for marine service. A series of compressors up to 227 meters cubed per minute or 8,000 CFM for the United States Navy. In the following years, Ingersoll Rand's turbo machinery division continued to pioneer for demanding applications such as oil production and steel making. By 1958, our first shrouded impeller multi-stage centrifugal compressor package was introduced. Less than a decade later, a successful four-stage open impeller prototype had been developed and a new highly efficient, compact and reliable compressor was born. In 1968, Ingersoll Rand launched this packaged integral gear concept known as Centac, a truly innovative design for centrifugal compressors. The new Centac series evolved into a broad line of centrifugal solutions in 5 platforms, from 35 to 425 meters cubed per minute, or 1500 CFM to 15,000 CFM. Centac solved many of the problems inherent to existing rudimentary designs of the day and established a gold standard of reliability, efficiency, and productivity. With lower power consumption at all loads by employing backward-leaning open impeller designs with inline diffusers. Use of vibration probes for real-time monitoring of critical parameters. Utilizing carbon ring seals that improve efficiency and rotor stability while decreasing leakage and ensuring 100% oil-free air under all operating conditions. Use of compact coolers reducing package size by 50%. Within 5 years, Centac had established itself as the market leader, and our Phillipsburg plant was quickly outgrown, and expansion plants were developed in the United States and Italy soon afterward. In 1976, the second generation of Centac, Centac 2, was introduced with improved energy efficiency and modular design for serviceability. Centac advancements continued through the 80s with a new 3-stage design, optimized to provide higher efficiencies than the previous 4-stage models. The market acceptance and operating track record of this unit was absolutely outstanding. The Centac 2 also became the compressor of choice for many emerging applications, such as high-pressure soot blowing and snowmaking. 1985 marked a significant milestone in Centac history with the introduction of a compact flange-mounted motor to the compressor package in flows below 85 meters cubed per minute, or 3,000 CFM. These flange-mounted designs appeal to a wide segment of the oil-free market. In just the last few years, Ingersoll Rand introduced a first-ever from atmosphere to 40 bar, or 600 psi, high-pressure Centac compressor designed for the bottle-blowing industry. Today, Ingersoll Rand manufactures oil-free centrifugal compressors all over the world in 4 locations: Italy, United States, China, and India. From pre-configured designs for large manufacturing to highly specialized designs for the petroleum industry, Centac has been a trusted partner. With the introduction of C1000, an all-new Centac platform, Ingersoll Rand has taken innovation to a new level. Backed by a global sales and service network second to none, Centac centrifugal compressors will continue to meet the needs of large capacity air requirements today and for the next 100 years.
When coupled with Ingersoll Rand's time-proven 2-stage and single-stage contact-cooled air ends, reliability and efficiency take a giant leap forward. The use of Ingersoll Rand's precision-machined steel rotors, high-quality taper roller bearings, and integral coolant flow paths delivers unmatched reliability. The 2-stage air ends are renowned for their trouble-free operation and low energy consumption. They provide increased reliability by reducing the compression ratio required for each stage, resulting in lower bearing thrust loads and hence increased air end life. They also have a unique coolant curtain that reduces energy consumption by injecting atomized oil into the airstream, significantly lowering the energy required for compression. 2-stage air ends provide up to 15% more air than an equivalent single-stage air end, while using the same amount of power. The R-Series delivers innovative design, and flexible choice.
Everyone knows that oil and water shouldn't mix. And when it does, the results can be devastating. Fortunately, there's a greener solution. Ingersoll Rand's Polyset. Once you've invested in equipment, you don't want to trust your baby to just anyone. You want the experts. Like our Centac Remanufacturing Center. We'll tune up a machine so it runs like new. Sometimes you want to put an engine in overdrive, and sometimes you want to cruise. Either way, you'll need precise pressure control for smooth handling. Shift to our variable speed drive for up to 35% less energy costs. Ingersoll Rand can lead you to a greener future with products and services designed for ultimate protection and sustainability. Join us for the ride.
We're always looking for a car that runs clean and cheap. Well, we're going to show you now a car that's primary exhaust is air. That's because its main fuel is air. And let's face it, air is plentiful and pretty cheap. Here's Jay Ingram with a car that's a breath of fresh air. Sorry, I couldn't resist that one.
Fueling your car costs a lot more than it used to. Wouldn't it be better if it didn't? There's a new kind of car set to hit the market in France that promises to go easier on your wallet and on the environment.
What is good in these kind of cars is that they are going to be pollution-free.
Guy Negre of Motor Development International, MDI, invented the Air Car. It's a small car with a big claim. 0 emissions when used for city driving. So what's the secret?
Secret? No.
Actually, it's called CAT, compressed air technology.
One of the special devices of our car is the tank. The tank has to be very light, because the car has to be light, and this technology that we are using is used also for the shuttle.
The lightweight tanks are made of carbon fiber and hold more than 52 gallons of air at a pressure of 4,351 pounds per square inch, PSI. On this amount of air, the car can travel 93 miles in the city. The air is forced through an injector to the engine where it expands, pushing down on pistons that turn the crankshaft to power the car. The engine is also specially designed.
So this kind of engine can work with very low rev. For example, on the bench right now we are running at something like 200 revs, but we can run the engine at very low revs. But for us it's not so important because we're going to stop the engine at the traffic light. We don't want the air to be used for nothing because the engine can start very easily. We need less than 1 rev to start the engine.
The engine's design allows multiple engines to be joined together, giving a car more power, which means each air car model comes with the option of a 2, 4, or 6-cylinder engine. These cars will also be a breeze to fill up.
If you fill the tank, plugging the car on a normal electric plug, you will fill it in more or less 4 hours. And here in Europe, that's going to cost about €1.50.
1.5 euros equals $1.95. The second way is to pull up to a high-pressure air pump as you would a gas pump. Then it takes a mere 3 minutes to fill your tanks.
And in this case, we don't exactly know the price because we have to design this air station. But we can imagine that the cost will be increased by 50 to 60%. So we may pay something like 2 to 2.5 euros for one charge.
That's about $3.26. And remember, you can travel 93 miles on that. To go to the same distance in a gasoline-powered car these days would cost you about $10. Right now, there are a couple of car models in the works.
The Minicat is a small car of 3 places, 2.65 meter long, and it has a very huge place inside. We've developed this car with all the technology inside of the car, which is under the floor. Like this, you can have a huge trunk for a small car, which is more than 700 liters, which is like a limousine trunk.
There's also the City Cat, a 6-seater sedan that could be the taxi of the near future, and a compact truck. Even industrial machines can be powered by the CAT system. The technology is ideal for city speed limits, 40 miles an hour or less. At those speeds, the car runs solely on compressed air, and the only exhaust is cold air, which can be routed back into the car to power the air conditioning. At higher speeds, however, it still has to run on traditional fossil fuel. Still, for densely populated urban centers, the air car is a clean alternative to today's vehicles.